this kit is called an Anti Landmine Rover. So this is a device or a system which is used to detect landmines wherever, and it has different applications in defense, military. So the thing is, there are two parts basically. One is the rover or the robot, which can be controlled wirelessly. So this is the remote. This is a remote control for the robot. So as you can see, so when these two buttons are pressed together, it can run in forward or backward direction, and when controlled diagonally, when press the diagonal switches, the robot can be turned. So this is the part of the robot, and the other part is the metal detector. So as you can see, this is a coil. So whenever any metal is detected within the premises of the coil, there is a buzzer which raises an alarm, and also an indicator, the light indicator. So you can order this kit from our website, kitsguru.com, where you'll find two versions of the kit. One where you'll get this complete ready-made kit, as you can see here, and the other one where you'll get all the components separately, and you can assemble them with the help of our video tutorials on how to assemble the components and also how to solder them. So in this section of the video, we'll see what all components are used in the kit, and what all are the PCBs, and how are the components fixed onto the PCB, what are the functions of each and every component, and how can you convert a set of components into a working kit. So as you can see here, we have a ready-made kit for reference. So you can see there are four main PCBs. One is the RF transmitter circuit, one is the RF receiver circuit, third one is the motor driver circuit, and fourth one is the metal detector circuit. So we'll start from the motor driver circuit, and we'll move on to each and every PCB and see how those components have to be assembled together. And so this is the motor driver PCB here, and for reference purpose, I'll keep my blank PCB in line with the ready-made reference PCB, so that it is easier for me to align the components correctly in the right direction. So a PCB has two layers. Basically, this is the top layer where all the components are inserted, and this is the bottom layer where all the copper tracks are present. So the technology that we use is called a through-hole technology, in which we drill holes throughout the PCB from the top to the bottom, insert the layers components from the top layer, and solder it at the bottom layer. So this is the motor driver circuit, and as you can see, first we'll start with the microcontroller or the motor driver IC. So you can always fix the ICs directly, but it is advised to use a base so that the ICs does not get damaged during the soldering process due to overheating, or you might also need to replace the ICs in the future. So it is always advisable to use an IC base. So this is the IC base. Then there are two connectors which are added, two terminals which are connected to the motors of the robot. So the two connectors or the two terminals go on either side of the IC. Then there is a 2-pin connector for the power supply. So we'll also tell you in this video how the power supplies need to be checked. And as an output, to receive the output signal from the microcontroller, we have a 4-pin connector base, and then we have a voltage regulator IC. Now when you take a look at this 7805 voltage regulator IC, the face which has the specifications written on it is the front face. So the left stem is the first terminal, then center one is the ground, and the third terminal is the output terminal, which generates 5 volts. So while inserting the voltage regulator IC, we have to ensure that the output terminal, that is the third terminal, is facing us. So the first terminal will be in line with the power supply, the first terminal of the power supply, positive terminal of the power supply. So this is how the motor driver circuit is completed. You also have to make sure that once you keep inserting the components, you keep soldering them. So we'll move on to the next PCB. So this is the transmitter, RF transmitter. So as you can see, so basically there are 4 switches. So we'll insert the switches. These switches are inserted, they control the movement and direction of the motors. So there are 4 micro switches. Now these micro switches, when pressed, turn on, and when left, turn off. So 4 micro switches come here. Then we need to insert a resistor of 1 mega ohm, color code brown, black and green, before inserting the IC base. So there are 2 types of PCBs. You might get any one of these from our kit, so you can connect accordingly. And then the IC base. So as you can see, there is a notch on this IC on the right side, a small notch when looked carefully. So while inserting this IC base in the IC, we need to ensure that the notch is on the right side. As you can see, the notch is here on the right side. So when you take a look at this IC base and the IC, so if the notch is on the right side, so as you can see, the notch is on the right side, so the top right pin will be the first pin, and then counting counterclockwise, the bottom right pin will be the pin number 18. So that is how you need to count the pins of the microcontroller. So the pin which is, if you keep the microcontroller like this, with the notch on the right side, the pin on the top right is the first pin, counting counterclockwise, bottom right pin is the pin number 18. So you need to insert the microcontroller IC base in the controller in such a way that the notch is on the right side. Then we connect the power supply. So this is the 2-pin connector, and then a diode. Now while connecting the diode, we need to ensure that the negative terminal, that is a terminal which is having a whitish gray strip on the black body, is a negative terminal. So the negative terminal has to be connected away from the 2-pin terminal, 2-pin power connector. As you know that the power current flows from positive to negative direction. So when the power supply is here, the positive terminal of the diode should be connected closer to the power supply. And then another voltage regulator IC, which is facing you. And then we'll connect the transmitter. Now this is a transmitter. So when you take a look at the transmitter, there are 4 terminals. So the antenna terminal will be closer to the antenna slot. As you can see, this is the antenna slot, which has a wire connected to it. So the terminal which is the antenna terminal will be connected closer to the slot. So you can take simply a wire and then connect it here, which works as an antenna. And then after that, you need to connect a network resistor. A network resistor is a cluster of 8 resistors of 10 kilo ohm each. Now this is a network resistor. So while connecting, you will notice that the network resistor has a dot on the left side. So the dot should come on the right side here. So as you can see, this is the dot. So this is how this needs to be inserted. So once this transmitter circuit is done, we'll then move to the receiver circuit. So as you notice, I'm keeping every PCB in line with the ready-made PCB, so it is easier for us to understand. So first, for the receiver kit, first we'll connect the power supply, a 2-pin connector base, then a diode. Again diode, the positive terminal of the diode will come closer to the 2-pin connector base. And then a voltage regulator IC. So the first stem of the voltage regulator IC will be in line with the diode. So this voltage regulator IC will be facing U. Then the IC base. So as you can see, the notch is on the left side here. So we'll be inserting the notch on the left side. We'll be inserting the base and the microcontroller in such a way that the notch is on the left side. So after that, there's an LED, as you can see. So LED has two terminals. One is a positive terminal, one is a negative terminal. So the stem which is longer length is the positive terminal, or in case both stems are of equal length, the bulb gets flat at the negative terminal. So the bulb is usually round, but it gets flat at the negative terminal. So while inserting the LED, we need to ensure that the positive terminal is on the left side. And then we connect a resistor for the protection of the LED. So this is a 1K resistor of color code brown, black and red, in order to protect the LED, and another resistor of 51K to support the receiver with color code green, brown and orange. And then we'll connect the receiver. So as you can see, the antenna slot is here. You can see here the antenna slot is here. So when you take a look at the rear side of the receiver, you'll notice the antenna slot or the antenna terminal. So this antenna terminal should be closer to the antenna slot. And then a 4-pin connector base in order to take the output from the microcontroller. So once this receiver circuit is done, we'll move on to the last PCB. So I'll tell you how the connections are done. I'll tell you how the components are fixed in it. So you need to keep your blank PCB with reference to this ready-made PCB, and then you need to ensure that all the components have the right specification. For that, with the help of this video, you'll also get a particular specification sheet with the help of which you can insert all the components. So I'll tell you what all components are in order. So these are the two connectors, 2-pin connector base. Then this is a 680 ohm resistor, then a diode. Okay, the negative terminal of the diode will be away from you. Then another resistor, as you can see here, this resistor is 15 kilo ohm. Then a 100 microfarad capacitor, electrolytic capacitor. And then a 2.2 kilo ohm resistor. This is a 2.2 kilo ohm resistor. Then a diode whose negative terminal is away from you. And then this is a 680 ohm resistor. Then an LED whose negative terminal is on the right side, which is facing the transistor. So these are two transistors whose flat surface will be on the left side, will be facing the LED. Then 0.1 microfarad 104 IC capacitor, which goes here. This is the IC capacitor. Then a diode whose negative end is away from you. Then another capacitor of 12 picofarad. So this is right before the transistor. This is the capacitor. And then another transistor whose flat surface is facing the LED. One after the other, two transistors. And then this resistor is 22K, and then another diode whose negative end is away from you, and then another resistor of 3.3 kilo ohm, and then another IC capacitor 0.1 microfarad, and then this is a preset. Then another resistor of 56 kilo ohm. This is a resistor of 56 kilo ohm. Then 102 IC capacitor, and then 270 picofarad capacitor, and then another 270 picofarad capacitor together, and then this resistor is 56 kilo ohm, and then this resistor is 2.7 kilo ohm. So you need to ensure that, and this is the coil, you'll be getting the coil ready-made from us. So you need to ensure that the directions of the diodes and transistors are proper. The resistors can be connected in any direction you want, and also you need to make sure that the connections, the power supplies are connected properly. So once the connections are done, we'll check the power supply. So this is a digital multimeter through which we connect the we check the power supplies. So the black terminal, that is the common terminal, has to be connected to the body of the transistor, any transistor, and with reference to which we'll check the power supplies. So the left or the first stem should show the input. So the left or the first stem should show the input signal, input power supply, and the third one should show the output 5 volts. So this has to be checked for every transistor, also for every voltage regulator IC. Then the last pin here should show 5 volts. The last pin of this microcontroller should show 5 volts, and the first pin of the motor driver should show 5 volts. Then here it should show, first pin would show 5 volts, and this terminal should show 12 volts or the input power supply. Then here it should show 5 volts, and then again 12 volts or the input power supply. So once this power signals are checked, you'll notice that all the connections of the power supplies has a positive terminal on the left side or on the outer side. So before finalizing the connections, you'll check the power supplies on the connectors. So as you can see, the left terminal is the positive terminal, the right terminal is ground, and even in this case the left is the positive terminal, and even in this motor driver circuit, the terminal which is on the outer side or which is away from you is the positive terminal. So you need to ensure that your connections are proper, and then you'll get this power jack. So you'll notice that there are 3 terminals on the power jack. So the one which is at the outer side, one which is this side away from the adapter, has all the positive connections. So this is the positive terminal of the power jack, the one which is away from the opposite end of the adapter, and the innermost terminal is a negative terminal where all the black wires can come and connect each other. So also you'll get a ply board along with all the motors and the caster wheels and the fasteners here, as you can see. So even a couple of wheels. So with the help of this plyboard, we'll be giving you the plyboard with all the necessary drilled holes and all the necessary fasteners and motors and the wires. So with the help of all these fasteners, we'll be able to connect the motors to the body of the plyboard and connect the wheels to the motor and finish the connections of the robot. So once you've connected all the components and then check the power supply, then if it is okay, then you can go on and fix your final transmitter, receiver and ICs. So you can order this kit from our website kitscrew.com, where you'll find two versions of the kit. One is where you'll get all the ready-made kit, as you can see here, and the other one where you'll get all the components separately, and with the help of this videos and our other videos on soldering, you'll be able to finish the connections and complete your kit.